Had a request to do number 24 from section 9.1. Forgive me, I'm in the middle of a hockey rink. I'm in the office space and people will be walking in and out. So first of all, you're going to take the list of data, the heights, right here, and you're going to put that in L1 in your calculator, and then you'll put your IQ into L2. So if I'm looking at my list, my calculator will have all of the heights in L1, all of the IQs in L2. You do have to make sure that your diagnostics are on to make this work. So the way you turn on your diagnostic is you hit the second key and then the catalog key, which is the number 0. Then you arrow down until you find diagnostic on, and you hit enter twice. Then you're going to hit the stat key, the calculate key, and then you're going to look for number 4, which is linear regression AX plus B. When you hit enter twice, it will give you this output. And I chopped off some of the decimals, or truncated, however you want to call it. A is 0.1316, B is 102.07, your R squared is 0.0025, and your R is 0.0509. There's two ways you can test for correlation. And basically you assume no correlation, because if I draw a normal curve, the 0 is where the bump of the normal curve is. If you don't have correlation, your R value is close to 0. If you have correlation, it'll be close to 1 or close to -1, depending on if you have positive or negative correlation, respectively. So if I do it quickly, which I call the quick way, I take my R value and I go and I compare it to Table 11 in Appendix B. The critical value that you get there, based on alpha being 0.01, is 0.834. You have to be bigger than that. The absolute value of your R has to be bigger than that for you to have significant correlation. Our R value is 0.05, which is way smaller than that. So we don't have correlation. If you're going to do it by the hypothesis testing way, again, here we have the assumption, or the null, being straddled over the 0. So what we do is we take our null hypothesis and we say our rho is less than or equal to 0, and we're going to do our rho is greater than 0 for significant positive correlation. So I'm making a claim, and forcing the claim in this case. I'm just assuming it because they didn't give us one. The taller you are, the higher your IQ is. So I'm thinking about this as a possible positive correlation, because they're both increasing. Negative correlation is when one moves positively and the other one moves negatively. So you're not going to get a p-value out of this. You're just going to get a t-statistic. This is the formula that you use. You go r over the square root of 1 minus r squared divided by n minus 2. Now, to get your critical value, you're going to do INVT, and you can do 0.016 and realize that you're going to get a negative value out of that, and because this is a right-tailed test, you'll make it positive. Or you can do INVT 0.99, 6 degrees of freedom, and 3.14. The 6 degrees of freedom comes from the fact that you have 8 data sets and you do n minus 2. Well, when you crunch this out, you get a test statistic of 0.124, which is not greater than or farther out into the rejection region. So it's sitting here close to the 0. So we're going to fail to reject the null. Our alpha is 0.01. And we have insufficient evidence to support this artificial claim that I created. So the idea is that your null hypothesis is that you don't have correlation. So your R value is close to 0. You have to show there's correlation. That's your alternative hypothesis. And so if they're both moving together, you're thinking of it as a positive correlation. If they're moving in opposite directions, you're thinking of it as a negative correlation. Hope that helps.